Power generation is a multi-discipline subject. This video covers the basic Generator 101 topics of electrical generation. For a basic understanding of electrical generation, we start with Ohm's law. Ohm's law is the formula linking amperes or current, volts, and resistance. From Ohm's law, we cover alternating current, more commonly referred to as AC current, and conductivity.
Named after Herr Ohm, the person credited with establishing the relationship between amps, volts, and resistance, the steady current through electrically conductive material is directly proportional to the potential difference, or voltage, across the material.
When an electric current flows through a conductor or wire, an analogy can be made to water flowing in a pipe, whereby resistance to water flow is the size of the pipe. The bigger the pipe and the wider the opening, the lower the resistance. Currents, or amps, is the amount of water flowing through the pipe. Voltage can be represented as the pressure of the water within the pipe. Therefore, the more pressure is applied, i.e. voltage, and the bigger the pipe is, the lower the resistance. Ohm's law states that in an electrical circuit, the current passing between 2 points is directly proportional to the potential difference applied across them. Where potential difference is voltage V and current is I, is a function of amps times volts, with amps having the designation I and volts V. Ohms determined that at a given voltage, when the resistance increased, the current flow between 2 points decreased, and the reverse when resistance decreased and the current increased. This is a very important relationship to determine the power required at a given voltage across a conductor, or resistance, between 2 points. Ohms determined by dividing voltage, V, by units of resistance, R. V over R equaled amps. The result equaled the amps, I, and the current flowing in the conductor. Hence, I equals V divided by R. From this formula, if two of the three factors are known, the remaining one can be determined. I equals V divided by R. V equals I times R. R equals V divided by I. As indicated in this circuit diagram, when a load is connected to an AC circuit, the electrical power to a connected load defined as resistance, R, can be calculated by the amps or current, I, being multiplied by the voltage, V, with the result expressed in watts expressed as W. A single watt is a very small unit in power generation. To reduce the size of the number, a kilowatt was introduced. 1 kilowatt is watts divided by 1,000. Alternating current, AC, is an electric current that reverses in direction between negative and positive, as opposed to direct current, DC, that flows in one direction, which in one cycle represents a generator rotor turning through 360 degrees, as a conductor rotates and cuts across lines of magnet force between the north and south poles of a magnet. Per Faraday's law, an electromotive force, or EMF, is induced into the wire as it cuts through a magnetic field. The amount of EMF induced into the wire varies on the angle that it cuts through the magnetic force. At 0 degrees, no EMF is induced. At 90 degrees, the maximum positive EMF is generated in the conductor. At 180 degrees, no EMF is generated. At 270 degrees, the EMF generated is now the maximum negative force. As the rotor turns through one complete 360-degree cycle, the voltage generated is the instantaneous voltage at any given point in the cycle. The actual rated AC voltage generated is the root mean square of the instantaneous voltages as indicated by the flashing white line.
We are experts when it comes to electrical generation and can help you with all of your generator needs.